Alright guys, the plan for today is that we will continue to look at the Cartesian plane, and for us today and really the next couple days we're going to be focusing on finding the slope of a line. Now, 5th period you guys started this a little bit, but it's probably good to be reminded of it since it was on a Friday. So your goals for today are we will find the slope of a line if given 2 points and a graph. These are notes over slope of a line. If you take a look at this sign, the meaning of this sign could have several meanings. You see there's a truck, there's kind of a wedge shape. What does it mean? Well, you have 4 answer choices there. Icy road ahead, steep road ahead, curvy road ahead, or trucks entering highway ahead. And if you've seen this sign before, it means steep road ahead. Now, when we see this sign, usually you see a percentage with the sign, and you see a percentage there. It says the sign, which means steep road ahead, and then it says 7%. The meaning of the 7% is this: the 7% is the slope of the road. It means it drops 7 feet vertically for every 100 feet horizontally. Or to show you a picture of it, it means that as you're going downhill, for every 100 feet that you travel horizontally, you have gone down 7 feet in elevation. Now, when we think of this, you see the percent sign, and percent, it's spelled, and I guess you probably know how to spell it, but it's P-E-R-C-E-N-T. And if we broke that word down into its root meanings, per means out of, and cent means 100. So 7% means literally 7 out of 100. Well, that kind of sounds like a ratio, and in fact, it is. So if we think of the change that's going on here, as you travel on this hill, if we were to write it as a ratio, it would be the vertical change over the horizontal change. 7 feet per 100 feet, or 7 per cent. So, what is slope? Well, in very simple and easy language, not really all that mathematical, slope is the steepness of a line. Slope is just steepness. It's the steepness of a line. Now, slope mathematically can be expressed many different ways. You see a formula there that says m equals y2 minus y1 over x2 minus x1. That's a mathematical formula. We will use that. I'll show you how to use it. There's also rise over run. If you are a visual person, you will enjoy rise over run because it's very easy to see. The next one says vertical change over horizontal change. We won't really use that a whole lot, but it will make you smart if you write vertical change over horizontal change this way, or at least it makes you look smart. Vertical change or change in can be represented by a triangle, which is the Greek letter delta. Vertical change is y. Remember, the y-axis runs up and down. Horizontal change, x. Remember, x-axis runs left to right. So if you write vertical change over horizontal change that way, you will look like you know what you're talking about, even if you don't. All right. 2 important things to note. A line has a positive slope. Remember, positive numbers and negative numbers are drastically different. While they look very similar, they are different in terms of their values. A line has a positive slope if it's going uphill from left to right. So as you read that line from left to right, and it kind of looks like it has that shape of the line that's off to the left-hand side there, that would be a line that has positive slope. Whereas if a slope is going downhill from left to right, we say it has negative slope. And that will be the case with all lines that have that same type of shape. All right, here's the first part of determining slope of a line, and that is to take a look at a graph. If you're given a graph, sometimes it's easier to see slope if you're given a graph. And when you see a graph, the thing you should think of is rise over run. Rise over run. Now, I'm going to go ahead and bring up another rendering of this graph. It's not as well done, but it's still there. First, you want to start with your lowest point. You start with your lowest point. So our lowest point in this situation happens to be right here. We're going to start at that lowest point, and we will then count the amount that we have to rise to get to the next point. So rise is vertical. Remember, rise is vertical. It's always going up or down the y-axis. So in our case, we have to rise, and we have to rise 3 units to get to the next, to get to the same level, I should say, as our next point. Then we do our run, or our horizontal change. We have to go to the right, which looks like we're getting more positive. So if we're going to the right and our numbers are getting more and more positive, then we would use a positive number for that. And it looks like our change is 6. So our rise over run is 3 over 6. Now, that might seem a little bit difficult right now, but if we reduce 3 over 6, it's 1 over 2, or 1/2. Now, I'm going to back up a little bit to the previous page, because it's a little bit clearer here. One of the things that helps me as I'm determining slope is I think of my x and my y-axis. Take a look at the values on the x and y-axis. You'll notice on the x-axis, things that are to the right of the origin are always positive, whereas things to the left of the origin are negative. And on the y-axis, things that are above or up from the origin are positive. Things that are down from the origin are negative. Now, what I like to do is this. I like to pick the farthest point to the left, whether it's way up high or way down low, or it really doesn't matter. I pick the point on the left because, remember, when we read lines to kind of determine, oh, is this going to be positive or negative, we read them from left to right. So I'm going to go ahead and pick the point on the far left. From there, I need to determine how can I get to my next point. Now, we could go at an angle, but that's not going to tell us the slope. That's just going to be traveling along the slope. So what we need to do is this. We need to implement rise over run. Rise is always vertical. So as I'm starting at that point that's on the far left, would I have to go up or down to get to the next point? Well, it looks like I'm going to have to go up. And it looks like I'm going to have to go up 1, 2, 3 units. Go ahead and do that again. 1, 2, 3 units. And it's just counting each individual space. So I've gone up 3. That is my rise. I'll go ahead and put it down. 3 over. Next, we'll do the run. The run is always left or right. Now, you'll notice I put a positive 3. The reason I put positive 3 is because as I was moving up, as I move up, my y values get more positive. So if I move up, my y values get more positive. I'm going to use a positive number. All right, next, we'll do the run. It looks like I'm moving to the right, and I'll go ahead and identify how many times. 1, 2, 3, 4, 5, 6. So my run, or my horizontal change, is 6. How do I know it's 6? Well, or a positive 6 and not a negative 6? Well, as I move to the right, x values get more positive. Once you have that ratio, you need to simplify it. 3 over 6 becomes 1 over 2. And that's just simplifying fractions. Hopefully you know how to do that. If you don't, you need to brush up on it. but rise over run is a way to find slope. Alright, we'll go through this real quick just because you've already seen it. There you go. Lovely. Alright. Notice that the slope is positive and the line is kind of increasing as we move from left to right. So the way to check yourself as to whether you got the correct slope is to say, hey, is my slope moving uphill as we look at it from left to right, or downhill as I look at it from left to right? Since it's moving uphill, I should expect my slope to be positive. And while 1/2 is a tiny number, it's still a positive number. So we did a good job finding it. All right. Next, here comes the fun part. And this is actually the part that I prefer because it's a lot easier for me to use the formulas because they always work out so long as you put them in the right way. And I'm going to show you a very easy way to put these things in. So, finding the slope of a line that passes through the points -2, -2, and 4, 1. If you're given points, it's always easier to use the formula. And that formula is m equals y2 minus y1 over x2 minus x1. y2 is the y-coordinate of the second-ordered pair. y1's the y-coordinate of the first-ordered pair. Now, what am I talking about when I'm talking about y-coordinates? Well, I'm talking about these things. I'm talking about the second number that is in each of those coordinate pairs, or those points, the point values. Please do not get x's and y's mixed up. Remember, x's come first, then y's. So if y2 is the second ordered pair's y-coordinate, you'll notice the second ordered pair is 4, 1. Well, its y-coordinate is 1, so that's why y2 is equal to 1. And in the first point, the y-coordinate is -2. That's why y1 is -2. So I'll go ahead and put those in. And you'll notice I also put in the x-coordinates. Now the x-coordinates correspond to the same points. If y2 is 1 and y1 is -2, then x2 has to be the x value that goes with y2, which happens to be 4. And x1 has to be the x coordinate that goes with y1, which happens to be -2. Now, I'm going to color code these so it makes it easier for you. So, let's take a look. I'm going to color code the first ordered pair in red and the second ordered pair in blue. Well, let's make sure that our x's and y's, if you'll notice in the formula, x1 and y1 are over top of each other, and x2 and y2 are over top of each other. So we want to make sure that's the case when we write down our formula. So let's find y2 and x2 because they should be vertical. Well, let's see, they were blue. 4 and 1. 4, 1. Yep, that works. You'll notice the operation that always goes on in the formula is subtraction. Now let's go back to y1 and x1, or x1 and y1. They were both -2s. There's a -2, there's a -2. They are vertical, over top of each other. We did a good job. Once you've got that, solve. When you solve, and it didn't pop up, it should have popped up, we get 1 minus -2. 1 minus -2 would be like 1 plus 2. 4 minus -2 would be like 4 plus 2. 1 plus 2 is 3. 4 plus 2 is 6. 3 over 6 is 1/2. Alright, you should have noticed, hopefully, that both of these were the same because the points were exactly the same. You can do these problems either way. If you know a point value, use a formula. If you see a graph, use rise over run. So, we're going to try some of these. Now, let's go ahead and practice now getting used to the formula because you will use this formula a lot. So we'll go ahead and write down the formula. M equals y2 minus y1 over x2 minus x1. I'm going to go ahead and pick one of the points to be my first point and one of them to be my second point. I'm just going to use the order that they come in, and I'm going to color code these. Here's my first point, and let's be festive. Here's my second point. I want to make sure that my first point's values line up over top of each other and my second point's values line up over top of each other. So let's make sure. I'll go ahead and just set it up here. Make everything look like it does in the formula. And now I'm going to make sure things line up. So let's go ahead and do y2 and x2. You'll notice that y2 and x2, I've gone ahead and just used -1 and 4. So I'll go ahead and put -1. That's the x value. X is always going in the bottom. Y is always going in the top. So y is in the top, x is in the bottom. Good. I've got a point that has values that are over top of each other. Perfect. Next, we write down the operation. It's always subtraction. It will never, ever, ever, ever change. Next, we write down the values of the next point. So, 3 and 5. 3 is the x, it goes in the bottom. 5 is the y, it can go in the top. After that, we solve. 4 minus 5, that's -1. -1 minus 3, well, that's -4. I have a negative divided by a negative. That would be a positive. 1 over 4, which looks like answer choice 3. And it is in fact answer choice 3. Let's try another one here. It says find the slope of a line that goes through the points -5, 3 and 2, 1. First, write down your formula. M equals y2 minus y1 over x2 minus x1. Once you have that written down, you can go ahead and pick one of your points to be your second point and one to be your first point. It does not matter which point you choose. I'm going to go ahead and use the red as my first point, and I will use blue for my second point, and I will put them now into the formula. So, set it up. The second point seems weird, comes first in the formula. The x's go in the bottom, y's in the top. Now the operation, subtraction, doesn't ever change. Next, we go ahead and write the values for our first point. So, x is -5. Y is 3. I'm going to go ahead and put my -5 in parentheses just so my -5 doesn't get mixed up with the minus sign. And we'll solve. 1 minus 3, oh, that's -2. Nope, that looks like a -3. There we go. 2 minus -5, well, 2 minus -5 would be like 2 plus 5, which is 7. We have a value of -2 over 7. -2/7. Now, you'll notice I'm going to bring up this stuff a little bit cleaner for you so you can read it. So there's the formula. There are those values plugged in. There's the simplification of it. There's our final answer. And we will get more practice with this tomorrow as well. Do not think that if you're not doing well with this now, that you're not going to be good at it. Trust me, you will be. It's just getting real hands-on practice with this stuff, okay? All right, next, let's try this one. You'll notice you have a graph. The easiest thing to do, rise over run. Now, what you need to do is this. Pick some distinct points. Let me show you some very, very, very distinct points. Here's one. Here's one. Those are distinct points because we have a specific place that we can go, hey, I see where this line is lining up. So let's go ahead and apply rise over run. I like to pick the point on the far left because we read lines from left to right. So I pick that point. Now I need to go, okay, am I going to go up or down? I need to go down. How many times do I need to go down? 1, 2. I went down 2. Now remember, on the x-axis, positive numbers are up, negative numbers are down from the origin. So as I went down, that was like having a negative number, -2, as my rise. So I'll go ahead and write that down. -2 over my run. Well, let's see. 1. I moved 1. Yeah, I moved 1. 1 which way? Well, to the right. Move 1 to the right. Remember, on the x-axis, negative numbers are to the left, positive numbers are to the right. So it must be a positive 1. So my rise was -2, my run, +1. So in terms of rise over run, -2 over 1, that looks like that doesn't look like something I've got over there as an answer choice. I've got -2, -1/2, 1/2, and 2. Well, maybe I could find another way to write -2 over 1. Well, if we think of any whole number written as a fraction, it would always be that whole number over 1. So in our case, we have a number -2 over 1. So really -2 over 1 could be written just -2, which is our slope. So in our case, -2 is the slope, which is answer choice number 1. All right, here's just another cleaner way to look at it. Find points on the graph. Ding, 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 ding. Again, I picked only 2 of them. You see that the points that are there, I picked that one and that one, but there were some other points you could have picked. Next, you need to use 2 of them and apply rise over run. Boom, boom. Oh my goodness, they started from a different point. Notice 2 and -1 were their rise and run. But when you put it into the rise over run ratio there, 2 over -1 still looks like -2. So it doesn't matter which point you start at. That's the nice thing about slope. You cannot be wrong in terms of which point you start on, so long as you go, okay, I'm going to do rise over run. As long as you do that, you're good. We notice also that the line is decreasing, so it makes sense as to why the slope is negative. All right. What about a horizontal line? What about a horizontal line? What's the slope of a horizontal line? Well, remember that slope is simply the steepness of a line. And at the beginning of the presentation, you saw that the sign that I showed you was the steep road ahead sign. Now, do we get warned of a steep road when you're driving on something that is flat? No, that doesn't make sense. The road's not steep at all when the road's flat. In fact, you don't have to worry about there being any steepness. And so because of that, when we see a horizontal line, we got to realize, you know what? while we might have a lot of distance we can travel, this thing's not going up or down. There's no rise to it. There's a lot of run, but not a lot of rise. So when we do rise over run, rise would be 0. Our run would be really any number because it's going to go on for a long, long time. Remember, lines go on forever. So if it doesn't rise, 0 is our rise over some number, 0 over some number, or remember, fractions are just another way to show division. 0 divided by some number is always 0. So the slope of a horizontal line will always be 0. What about a vertical line? Well, let's think about vertical lines. Vertical lines definitely have a lot of rise, but are they going to run? Are they going to move anywhere in terms of like traveling left and right? The answer to that is no, they do not have any run. So if we use rise over run, yeah, you'd have some number for your rise, but your run, it doesn't have any. When we divide some number by 0, and you could try this in your calculator, you've probably done it in the past. If you divide any number by 0, like you type in some number, divided by 0, you usually get some kind of an error, like error divided by 0, or syntax error, or something along those lines. What that error is saying is that you're no longer working in the real number system. You're now working in a thing that we call imaginary numbers, and calculators don't really know how to work with those, and so they go, oh, that's an error, I don't like that. And when in all actuality, that number is simply undefined. So all vertical lines will have an undefined slope. So if you ever see a horizontal line, slope is 0. If you ever see a vertical line, its slope is undefined. The way to remember that is the word vux hoi. Now that sounds really weird and probably doesn't make sense because it's not a real word. It's just an acronym like ASAP or AWOL or something like that. They're things that don't really make sense in terms of their wordage, but when you go, oh, hey, this stands for something else, then it makes sense. So vux hoi stands for this. V stands for vertical lines, have an undefined slope, u, and they will always start like this. X equals some number. That's going to be the equation that they will look like. So if you ever see an equation that says x equals and then just a number, it's a vertical line. So vertical lines have undefined slope. They will always start x equals some number. The H stands for horizontal lines. They have 0 slope. And I know it's an O, but 0, they have a 0 slope. And they always start y equals a number. So if you ever see an equation that starts y equals and then just a number by itself, it's a vertical line. So vertical line, or sorry, not a vertical line, a horizontal line. I said that wrong. So vux hoi. Vertical lines have undefined slope. They always start x equals a number. Horizontal lines have 0 slope. They always start y equals some number. All right, we're not going to worry about drawing the line today. I'm going to go ahead and stop there. Tomorrow we will plan on working at finding slope and getting a little bit more practice with it. For the remainder of today's class period, we've got a little bit of time left. What I want you to do is this. I want you to go ahead and if you have any work from other classes, you may work on it. Consider this my Christmas gift to you, that you can catch up on some work before you have to go off onto Christmas break. So enjoy that. Try to get as much stuff done as you can. Take advantage of this opportunity. If you are done with everything, you may talk quietly. However, please make sure that that keyword of quietly is observed quite well. Okay? And I hope that you guys have a great rest of your day, and we will see you tomorrow. Thank you very much.